Thank you everyone for attending for this, very distinguished lecture entitled A Hands-on Approach in Cybersecurity Education, presented by the world-class scholar and very well-known worldwide distinguished Professor Kevin Du. Professor Kevin Du from the Department of Electrical Engineering and Computer Science in Syracuse University, United States. Short bio about Professor Du. Dr. Kevin Du is the Laura J. and L. Douglas, a professor of teaching excellence at Syracuse University. He received his bachelor degree from the University of Science and Technology of China in 1993, and he received his PhD degree from Bordeaux University in 2001, all in computer science. He is currently a professor in the Department of Electrical and Engineering and Computer Science at Syracuse University. His background is in computer and network security. His current research interests focus on mobile system security. He's also interested in developing instructional labs for security education. His research has been sponsored by grants from National Science Foundation, NSF, Army Research Office, JP Morgan Chase, and Google. He's a recipient of the 2013 ACM CCS Test of Time Award and the 2017 Academy Leadership Award from the 21st Colloquium for Information System Security Education. Also, he has published a book, second edition, on computer and network security. I leave the abstract to be presented by Dr. Kevin himself. Dr. Kevin, we are very pleased to have you with us today. Okay, we are all ears to your interesting talk.
Well, thank you. Thank you very much, Dr. Musa. So let me share my slides. Yeah, thank you for the invitation. So this is a great opportunity. And so I hope you guys have a very good weather. I'm here, we are snowing. So let me share my screen. I hope you can see my slides.
Yes, we can see them.
Okay, great. Yeah, so I'm gonna get started. So I'm doing the full screen. Yeah. So while I'm doing the presentation, I'm not able to see the chat window. So if you have any question, probably have to speak up.
Actually, we'll leave like 15 minutes at the end for the Q&A. So if you have any questions, please write in the chat window. I'll collect the questions, then we can have like 15 minutes at the end to answer the questions. Is that okay?
Yeah, that's great. That's great. Yes. So if there's any issue with audio, something that you probably have to let me know. Otherwise, I'll just keep going, assuming there's no issue. Okay, so yeah, so let me get started. Yeah, so I'm going to talk about the hands-on approach in cybersecurity education. And so mostly I'm going to talk about the SEED project that I have been working on for the last about 20 years. First, I'm just going to give an outline what I'm going to talk about. So I will talk about my teaching philosophy. So what is the philosophy behind the design of my SEED project? And then I will go over the overview of the SEED project. And some of you probably already know, but most of you probably don't know and what is in the SEED project and what you can do with the SEED project. And then I'm going to talk about the next phase of the SEED project. So I've been working on this for 20 years. So for the next 20 years, what I plan to do. Okay. I'm going to start with a very famous quote, and many of you probably already know or hear a different version of this. This basically is the foundation of what I'm doing. So it's basically says if I hear something I forget, I see something I remember, if I do something I understand. And really, this actually emphasizes the learning by doing. And this is a quote that many educators use and to support and why, and they actually promote the learning by doing. And there are two more quotes which I got from Peter Dennis, and who is a very famous computer scientist, and he's one of the pioneers in computer science. And so he has these two quotes, and basically the similar things. And he wrote an article titled "Principle of Computing" in the article, and this is what he says. So if we adopt a picture that ignore practice, our field will end up like the field new mass, and all concept, no practice, lifeless dead. So, and then the next one is our competence is judged not by our ability to explain principle, but by the quality of what we do. Many of the professors, and including some of my own professors, and when they teach computer science or computer security, and they spend a lot of time teaching the ideas, the principles, and even when they talk about the attacks, they talk about the attack on paper, and that's huge gap between the theory and the practice. So when I first actually become professor here, and I was doing similar things, I'm teaching students the idea, and then I tell the students, so here's the problems, and why don't you actually launch an attack on this? And since the idea is very simple, we only spend 15 minutes to talk about idea, and I will give you 1 week to do the attack. It turns out that my best students spend half a semester and to be able to do that simple attack, which we covered in 15 minutes. So that really strikes me, the huge gap between the theory and the practice. The reason why my students spend half a semester is not because of the students are not good. Those are my very good students. It turns out for that particular attack, there are 4 lines of countermeasure already implemented inside the OS. So when we teach theory, and we did not teach about those things. So we, of course, we teach about the countermeasure, but we teach about only the theory part, not the particular, the practical part. So the student had to actually overcome those 4 lines of defense eventually, and to be able to launch an attack. So that's something you don't want a student to spend half a semester just do one small things, right? So that really motivated me to think about, and what can I do, and to bridge the gap between the theory and the practice. So that's actually the foundation for my project. So back to 2002, and when I start teaching, I do want students to actually do hands-on project, because I strongly believe in learning by doing. But when I look at the internet, and these days, if you need something, you can always find it from internet. But in 2002, I wanted to find some hands-on project that I can use, but I couldn't find. There are a few, but if you use them, it takes you half a semester just to learn how to use them. And then once you learn how to use that, then the semester is almost over. And so that's not something that I want. I want to have something that I can immediately use, but there was no such a thing. So I decided just to build my own. And not only just for myself, I wanted to be able to share with the others. So other people, they don't need to spend similar amount of time, and they can easily use the lab. And so I actually laid the criterion. So if I build a lab, and what do I want to achieve? Now, first things I want to achieve is I definitely want this to be low cost, free for students. I don't want the students to spend a lot of money, or the university spend a lot of money just to purchase some of the labs. And there are some of the commercial lab, and you have to buy them, but I really want this to be free for students. And also, I don't want this to be tied to any dedicated hardware, because if you do that, then a lot of a school or university, and if they don't have enough budget, they will not be able to create a lab. And I want this to be on either student computer or on some general computer. At that time, the virtual machine technology was just starting to take off. So I really just jumped on that wagon and used the virtualization and build the virtual machine for that. And the second thing is I want this to be high quality. And I want the activity to be valuable, interesting. I want the student to like the activity, and they feel they want to do the lab, not just, they are forced to do the lab. And so that requires a lot of constant improvement. So over the last 20 years, and many labs, they have gone through many rounds of the improvement. And some of the ones that you see, they are already, they have been improved many times. There are many other labs that I eventually discarded because either they are not good enough, they are not interesting, and so you don't see them on my website. And also I want the task to be very concrete, well designed, and so students know exactly what they expect to do. And so they don't need to, figure out what do you mean by this, what do you mean by that. So that's going to save a lot of effort from the professors. And I also want to have a wide coverage. And I want to cover the fundamental. I don't want to just cover everything, because cybersecurity, and there are so many things you want to cover, but underlying principle are pretty much the same. I want to focus on the underlying principle and not necessarily on all sorts of these fancy attacks. Many attackers, they have the similar idea. So I don't want to duplicate them too much. So I did look at some of these classic attack and some of the modern attack, and I picked the one that I think have education value. And also efficiency is very important. Students only have, let's say 5 to 10 hours per week and for your course. And you don't want a student to spend 20, 30 hours just for your course, because they have many other courses. And so some of the lab tasks, and I have to look into whether this is essential for security. If it's not essential, even though they have a value, but they just take too much of students' time. For that kind of things, I find a way to minimize, to simplify, so I can keep students to focus on the essential part of the attack or the task. And as a result, so I have went out to National Science Foundation to ask them to fund my research. And NSF was very generous, and they've been pretty much funding my project for the last 20 years. And so I went through actually 3 different phases. Each phase is a different grant. So over the years, now I have about more than 1,000 schools using that. I don't know, the actual number, but everything's online, it's free. You don't need to tell me that you are using that. And these are the schools that it tells me that they are using that. That's why I got this number. But the actual number could be higher. And there's been wide adoption. The university, colleges, the community colleges, even high school are using that. That was not expected. When I designed this, I was designing for the college and the university. But I find out some of the high school, especially some of the more advanced high school, they even offer the AP courses on cybersecurity for students. And in the US, there's some statewide adoption. So Virginia, and they actually incorporate those labs in their cyber range. So that was very good to hear. And most of the military school that I know about, the Army, the West Point, the Air Force Academy, Navy Academy, and the Coast Guard Academy. So all of them are using the labs. And also I heard the companies, and they are using those labs for internal training, for interviews. Some of my students told me that when they interview with some company, the company just pull out one of seed lab, ask them to work on that. So that was quite interesting to hear. Some security clubs, individuals, so it's been widely used. The environment is these days is quite standard now. It's basically the virtual machine. So I built this virtual machine and image. So you don't need to actually install anything. All you need to do is to install VirtualBox. So that's open source, and you can install on any OS, Windows, Linux, Mac. And even if you use VMware, it's fine, but I'm only officially support the VirtualBox. The virtual machine image that I built, and right now we are using 1604. And I also have a 1204, but we are doing most of the work in 1604. And also for Android lab, and I also built an Android VM. And the instructor just need to ask students to download the virtual machine image, and that's it. Everything that is needed by the lab has already been installed. There's no additional effort from the professor. And you can deploy that in many different ways. My favorite way is to just let students download everything to their personal computer. These days, most of students, they have a personal computer. So, and they find it more convenient to work on the lab on their own computer. You can run multiple virtual machine the instance on your personal computer. Some lab, they require about 2 to 3 virtual machine the instance. And that should be easily actually doable on the typical personal computer. Some universities, they are required to provide the computer support for students for that, and you can just install the VM and the VirtualBox in some of the computer labs. Some of university, and I know this is what they have been doing. And you can also do the cloud and the My Image, and you can also just pour that into Amazon Cloud and then ask them to do it from the cloud. And any method is fine. I've tried all of them, but I really personally recommend using the student personal computer, and because this is the most convenient way to do that. And if you go to my website, and you will be able to see this page, and these are the categorization of the labs, and there are, I think, more than 35 labs in there, and there are software labs, software security, network security, web security, and most of the lab I think you're going to find in the software and network security and the crypto lab. And for the web security, there are few, and the mobile and the system, there are few. And in the future, I will actually trying to increase the number of those categories. Now, there are 3 types of lab and that I want to talk about. So when I design this, I want the expose students to all sorts of different skill, not only just on the attacks. But so I have this attack lab, which pretty much just focus on attack and the defense. And then I have I call the exploration lab, and these are mostly defense oriented. The goal is to help students understand how things work, how the defense mechanism works. And I did a lot of simplification. So there are some of the very complicated defense mechanisms. I simplify them so students can understand its core idea. And then the third one is called the design and the implementation lab. And those are for students to build something and themselves. And this is a more comprehensive lab. Now for the attack lab, most of the lab I designed, they are attack lab, because these are the things that the students most interested in. And when they start security, and many people are drawn to security field because of all these attacks. So I want to expose students to all these kind of attack, especially the classic attacks, buffer flow, and the race condition, cross-site scripting. So you can see I'm trying to turn these classic attacks, those textbook kind of attacks, and into a hands-on lab. So when the professor teach those attacks, and they can easily find a lab activity for students to work on. And so on the left side, you can see there are a lot of the software security lab, web security lab, and the mobile security. On the right side, and many of them are the network security and the crypto. And some of the lab, and I have not actually made public yet, so those are these like IP, ICMP attack. They are still in the beta version. I'm still testing that in my own class. Midnight attack, those are, you won't be able to find them, but probably in a few months, and they will be made public. And not only just the classic attack, I also want the student to look into some of the new attack. And I kept a very close eye on this news. And for example, when the dirty cow and the shell shock attack and was discovered, and I immediately look into that and to see whether this is something that is interesting. And if it's interesting, and then can I immediately develop a lab for that? And some of the lab are easy to develop, shell shock and dirty cow. That didn't take a lot of time. But the meltdown and the Spectre attack, which just was discovered in 2018, and those are very difficult. So I end up hiring 2 students, and each of them spend 1.5 months and to learn how the attack works. And then they have to teach me, because I don't have a lot of time to learn everything by myself. So I hire students and to figure out all the details, and they have to come to teach me. And then I'm using my expertise to turn that into a well-designed lab activity. And so students in my class can work on that. So these are kind of extreme. It took us about 3 months, 3 of us, and to work together. Eventually, we designed these 2 labs, and now all my students, and they can spend 1 hour and to be able to understand something that took us 3 months to understand. So these are something that I really want to do, and to spend the time and so simplify things, but without taking away the core idea. Okay, I took away a lot of this the fancy stuff, a lot of the non-essential part, so students can really focus on this core idea. Like in Meltdown Spectre, it's mostly about the race condition, it's about the out-of-order execution, it's about the CPU, and so those are the things I want to keep. And now the student can work on this lab, and they can easily understand the main idea behind that. And I'm developing more at the attack or defense mechanism, and based on the new technologies and the new discoveries. Now for exploration lab, the main idea is to explore how security mechanisms work, and then so students can apply the principles to evaluate those mechanisms. And some of the labs, they include the SetUID lab, firewall labs, encryption, public key, PKI, and I'm currently developing the container and Docker lab, so help students understand the technology behind the container, and also the Bitcoin and blockchain. I'm building the set environment and a Bitcoin simulator, so students can actually do the trading, and they can actually do the mining in the simulator, and hopefully that can help them to understand the main idea behind the Bitcoin and the blockchain. And for the design and the implementation lab, the main goal is to get students to build things. They can do the attack, they understand how the defense, but for this type of lab, they got to do these things themselves. They got to build things, they got to develop the defense mechanism, applying what they learned and into their own system. They learned so many mistakes other people's made. Now it's time for them and to develop the system which do not have those kind of mistakes. And there are not many actually labs like this, and because this is very difficult to develop. Over the years, I have to develop a few, but only these 2 survived, the Firewall lab and the VPN lab. And the VPN is my favorite. I'm using this every year in my network security class. The goal is I'm asking students to develop a VPN from scratch. And we're not using the VPN software. They have to just write everything from scratch, either using Python or using C. The firewall is similar. They have to write a very simple firewall and from scratch. And in the future, I do plan to develop some more, and like encrypted file system, basically how you can integrate the crypto and with the operating system, and also the access control lab, and to help students understand how the access control works. Okay, so those are the existing labs that I've been built, and you can find all of them from the my website. And now I'm going to just talk about something that I've been doing right now. So I've been keep developing the lab, not only just to continue adding the new content and to those set of the lab, which I'm doing. Every time I see something interesting, I will add that. But I'm mostly talk about something that more ambitious than that, not just incrementally adding things. Now, one thing I want to do is to kind of reduce the requirement on C programming. And I got a lot of feedback from the instructor. And initially, when I developed lab, that was mostly for CS students, and because I'm from CS background or CE background. But more and more students are using that. So some of the professors told me that their students do not know C programming. And C is not necessary for many of the lab, but because that's I was familiar with C, that's why I use C. But then after hearing the feedback from the professors, now I start to add in the Python version. So now if you see a lot of labs, they have this Python code. And actually, I'm adopting the Python as the main language for most of the labs. I do keep the C version. Some of the lab, I do want a student to write in C, but I'm leaving that to the instructor to decide whether they want a student to work on C or Python. So it's the choice from the professors. And I'm also developing this capture the flag lab. Most of the lab that you see, they are standalone lab. So students, they just work on this and they can do it at home. And those are good, but they will be more interesting if students can do the lab in a competition environment. So I'm trying to turn some of my lab in this competition, so CTF. So in this way, the student will come to and they're going to actually do the attack in the classroom. And you can see this involves a lot of the software development. So I actually developed this platform for the CTF. It's still work in progress. I'm not ready to publish it yet, but in the future and when the software gets stable, and I will publish that. And so you can see I'm here, the instructor can provide this add a session. So each session is a team. So, and there are levels. So we have for the buffer flow, we have 4 different levels. If students start from level 1, if they succeed in level 1, they can advance to level 2, level 3, and level 4. And the instructor can easily create a session for students. And then this will be projected to the screen. So when the competition starts, every team is going to have this block. And if they are successful and their flags, it's going to be displayed on the screen. And this is where students get excitement. So, and this is, when I try this in my classroom, when the students see their flag coming up, they're so excited. And that's the fun part that you don't get when you do that at home. And so that's actually motivated me to actually turn more labs into the CTF style. So it's going to up to the instructor to decide whether they want to do it in the CTF style or just assign them as homework. And I'm also trying to develop the simulator for cybersecurity education. Most of the lab in the seat, you can see they are most in a small scale. They involve maybe 3 or 4 VMs at the most. Some of the attack, you probably need 100 computers or even 1,000 computers, right? So to be more realistic. And some labs, you can't even do that, like the power grid and the automobile. And if you want a student to launch attack on the automobile, that's no way you can do it at this point without exposing student to the dangerous situation. So I don't want to do that. And that actually get me to think about to develop simulator. So I've been developing also all sorts of simulator, and that can be used for cybersecurity education. I will show you one of the examples. So the internet simulator, and all of these are work in progress. In the simulator, I've been working on that for over a year. The idea is I'm going to actually host a simulated internet, and student will, when they need to actually access the real internet, they have to go through my simulated internet. I call the shadow internet. So all of them have to go through my simulated, and this is running on the cloud. I can easily simulate hundreds different machines, and then I can simulate the Google network. I can simulate any IP the address. So let's see, student want to access Google, and they have to go through here in my simulated network, and they will be able to get Google. But once they reach my Google node, and they will go out and to access real internet. And it will slow down a little bit, but by introducing this shadow network, now I can launch the attack now, because I cannot launch the attack on real network. It's illegal. You cannot do that. But now I can launch attack on the simulated internet. Now, for example, if you want to simulate hijacking YouTube, which happens in the real world, And you want to do that, how do you hijack in the YouTube? And that involves BGP. So all you need to do is to launch a BGP attack inside the simulated network. And then the student won't be able to access YouTube anymore because they have to reach YouTube from my simulated network. And this way, and the student can see the impact of the attack. And everything is contained inside of my simulator. And this is something that I've been building. I'm very excited about this. I'm trying to, we have a proof of concept, but not ready for the public use. And over maybe in a month or two, I may reach out to some of professors to ask them to test the simulator that we have been building and to see how that goes. And also I have the IoT device, simulated IoT device. We already built a lab, which is ready to go. And this week, I'm probably going to actually make it online. And this is related to the DNS attack, how you can use the DNS rebinding attack and to attack the IoT device. So in this case, there's an IoT device, which is behind the firewall. And then there's a attack website. And if you actually visit this attack website, and this attack website can send out a request to the IoT device to raise the temperature to any arbitrary value. And so that's something that we can see. We have this IoT simulator, and this is basically a web server. And then we have this the attack setup. I will put on this on the SID website in probably today or tomorrow. And I've been doing the test and for the last few months. And the lab, not only just labs, and actually they build a lot of resources to help the professors, help the student, and to use this lab. And these are one of things, the instructor manual. And I actually basically combined this the lab report and put them into a menu. And I do not give this menu to students. So if you're a student, you shouldn't ask me for the menu. I only give it to the professors. And I usually mail to the professors, and if they request, and the menu is free, but the professor just need to cover the printing cost and the mailing cost, and I will be glad to mail them. And the book, and I spend a lot of time writing this book, and the book, and is based on my hands-on approach. Basically, it is based on my SID lab, and you will be able to find a lot of the SID lab in guideline instruction, the demo in my book. I'm trying my best not to do exactly what the SID lab is doing, because I don't want to give away. I'm always trying to find a variation and then talk about this solution to those variations in the book. So the student don't copy exactly what I put in the book, because otherwise that defeats the purpose of the labs. I'm trying my best to make them different, and you will find sometimes it's just difficult to make them different. And the book, I divided them into 2 different volumes. And you from Amazon, you can see, I mean, there are 2 different subsets, but they just make it easy for students, because this is a combined book. They have everything, but there are more than 1 course or worth of content. Even I'm using this book for 2 different courses. So I divide them into 2 different, so depending on whether you are teaching 1 course or you want a student to learn the topic in both. And they do have overlapping, not just completely disjoint. And if you're an instructor, and you can find the PowerPoint slides, and you can find the code in the GitHub, and you can find the problem set. I have about 300 different problems that you can use for homework. And those are what I call the attack on paper. And sometimes, I mean, doing attack in real, and students are subject to a lot of restriction, but when I put on this theoretical question, now I can put in a lot of different the condition, different assumption, and to test whether students fully understand that. So this should be supplement to the hands-on lab, and the students find this very useful, and when they actually prepare for the final exam, to test whether they fully understand the concept. So if you officially adopt my book, I will send you the solution, and not students, I mean only the professors. But this is I'm only sending this if you officially adopt this book as a required textbook, and not just, I mean, using the book. And the book you can find from these different places, and the Amazon, German, and if your bookstore, and you can get it from the Ingram. I have also recorded my lecture, and I did a demo in my lecture to show students how this the attack works. But I'm not giving out all the details, because I do want students to figure out some of detail, not just to follow my lecture. And my lecture emphasized the most critical part and some of the common mistakes that student makes. And this is my first lecture, which I just published in about 2 weeks ago. And it only covers about 11 labs, I think 11 labs, no, 9 labs and 11 chapters. Yeah, I will be building the more lectures, and this is more on the software security lab. I will be building the network security, and hopefully by May, I can publish my second Udemy course, so you can actually look at that. I've been hosting workshops, and in the past 5 years, these are some of the pictures, and just 2 months ago, I was in Riyadh, and I was hosting the workshop, and you can see these pictures. That was a very intensive, the workshop. We spent 5 days, every day we spent 8 hours working on the seed lab. And I really enjoyed that, and I hope the participants also enjoy that, and I hope to do that more in Riyadh. So I'm going to spend a few minutes just talk about the next phase. So I talk about what I did in the last 20 years and what I've been doing, and so what is next that I've been trying to do. I want to take my seed project to a different level. And so far, I've been mostly living off the government's funding and to work on that. But at this point, I just feel that the amount of money that the government provide to me as the funding is not enough for me to pursue the ideas that I have. So I have decided, and I have working on that, trying to do the transition. So instead of relying on the limited funding from the government, and I'm trying to see what I can bring in on my own money. And the only way to do that is you got to form your startup. So that's what I'm doing. I'm trying to form my startup, and so I can actually find a way to make money, so I can actually keep developing my lab. And I'm trying to use this so-called Freeman Model, if you're familiar with that. I don't want to turn the existing lab into the paid. I mean, if you've been using that, I want people to keep using this lab that I've been developing, and I will keep improving them. And so this is I call the free part, and there will be a standalone lab. What I'm trying to do is to find the way and to actually bring in the money through the added value, and not just to ask people to pay for that. I will not ask people to pay for those existing labs, but I'm trying to see what I can provide the online or on-site training, and I'm trying to build a simulator-based lab, which I'm going to host on the cloud, and that will be probably through the membership, and also I will turn many of my lab into cloud. So the student can either download the lab and do it themselves, or they can actually use my cloud service. So this is something I've been thinking. I mean, I'm just getting started, and whether I'll be successful or not, and I don't know. But my goal is I do want to keep my seed project going for many, many years until I retire, even after retirement. So I don't want to, I spent 20 years working on that, and with so many people using that, I want to keep it going. And so to summarize what I want to do, and I'm using this picture to summarize. So whether my startup is going to be successful or not, so I don't know, but it doesn't matter whether it's successful or not. I will keep doing this and for the next 20 years. And most important things, I want to keep developing seed lab. I have a lot of interesting ideas after 20 years of teaching experience, and I'm getting better and better in turning these security principles into the hands-on activity. I want to develop more. So those are probably primary things that I'm going to work on. And the book right now is in the second edition, but I still have a list of things I want to write, and I'm actually going to keep writing that, and hopefully in a year or two, and I'm getting my third edition out. And so, and similarly, and the lecture, the seed lecture, I've been recording lecture, but I want to, for every single chapter of my book, for every single lab that I develop, I want to build a lecture, and so the student can actually use this lecture to supplement and their actually hands-on experience. So that's something that I've been building. And developing lecture is a very time-consuming. For every 1 hour of lecture, you should take 10 to 15 hours and to build this lecture. So I'm going to take it slowly, and so I don't get burnout. And also, on top of that, I want to provide the workshop, so I can provide the training and to professors and training to students, and also the training to the software developers, so people who already are working in company and they want to actually enhance their the hands-on the skills. So I want to provide this kind of workshop, and this is part of the startup, and to see, I mean, whether we can keep going. Yeah, I'm already having a few customers that I'm working on, and I want to develop this high quality and the training program and to them. So that's what I plan to do, and just to summarize these 20 years of experience. So with that, I'm just going to stop here because it's 45 now. So thank you for listening to my talk, and feel free to ask questions. So I'm going to hand it over to Dr. Musa.
Thank you very much. Shukran, Professor Kevin.
Thank you.
Yeah, we are very glad to have you with us here. Actually, it was my first opportunity to meet you personally, like back in December 2 months ago during your workshop in Riyadh. Personally, it was a very rich experience. I learned a lot over a very intensive week, actually. And I felt at that moment that you are trying as much as you can to transfer the knowledge for us after your 20 years of experience or working on that big project. As you said, more than 1,000 universities worldwide are using this very interesting project, and we are using this currently with our students, and they are getting very much benefit out of it. I leave the floor now for the audience to have their own questions. Can you please see the chat window?
Yeah, I can see the chat window. Yeah, I can see that.
Yeah. If you have any questions, please, raise the questions? It's better to write it down, please. In the meanwhile, I'd like to ask, any plans to integrate digital forensics?
I definitely want to do that, but I need a partner, because this is this is a part that I don't know much about, the digital forensics. Yeah, so I'm actually for the startup, and I'm trying to find the people who actually knows about the digital forensics, and then work together and to develop the labs. Yeah, so I'm looking for people. Yeah, I cannot do everything. I'm trying to. One of the reasons for having this startup is really to find a partner, so I can actually make it the bigger. Not just doing something that I know how to do, but make it broader.
Yeah. Okay, understood. Yeah. Now some of the questions from Abdullah: how we can get the instructor manual? You are a student, Abdullah. He's one of my students, so you cannot you cannot get the instructor manual. Yeah. That's my answer.
Yeah. So let me tell you a story. So I'm using the Amazon for on-demand the printing. So Amazon requires me to put a price on the menu, and I don't want to sell the menu because I don't want the student to get it. So Amazon asked me, if you want to use my service, you got to put a price. So I asked Amazon, what is your limit? It says $1 million, and they said $3,000. So I put a $2,900 on my price tag. So if you really are desperate, you can buy it. But
Yeah.
if you're a professor, don't buy it and just send an email to me, and I will give you one for free as long as you cover the mailing cost. So far, one desperate student bought one copy, and I don't know who that student is, but that was funny. So, and you can find it in Amazon, but you should not buy it. So.
Yeah, actually, I recall that you mentioned something about trying to embed these labs in your son's schools, and they have some worries in that school. Can you remember that story when you said that your son was planning to implement seed labs?
Yeah. So my son want to have a security class. So he wanted to do this in high school, but the principal was very scared, so he never got a chance to actually to hold his class. So that's the difference between the high school and the college. So
yeah. Actually, I have now 3 questions.
Yes.
One from Mishari. What do you recommend for learning seed labs from the beginning? Is that?
Yeah, so I think from the beginning, and if you look at the my book chapter, if you follow that as a sequence, and that will probably be better. Yeah, so the first chapter on the set UID mechanism, those are the get you to understand some of the security mistakes made by the program. Those are easier lab. So I think starting from that, and then you go to a share shock lab, and those are easy one. And then when you go to the buffer flow, return to libc, that will become more and more difficult. Yeah, so each lab, I want to make them self-contained. Yeah, but some of them are difficult, some are easier. If you look at my website, the website, on the list of the lab, you can see actually some of the difficult level, and I have a low, medium, high, and that give you ideas and how difficult that is. Yeah, starting from that, follow the sequence of the chapter. Yeah, you can look at the chapter table content from the book website, even if you don't have the book.
Okay, yeah. Another question from a student, he or she put his number or her number. Is there a free copy of the book for students?
Unfortunately not, so.
Yeah, not at the moment.
I will be broke if I do that. So.
Yeah. Any plan to manage a workshop for SEU students? I answer this question if you allow me. Actually, now we are adopting seed labs, and starting from this semester, we'll try just like having one lab for each course. So in general, for whole curriculum, we'll have like 8 to 10 labs implemented doing face-to-face classes. In some courses, we will have some of the labs as a project at the end of the course. Yeah, we have now a question from Saud Al-Ghamidi. Any plans to develop a lab for Docker alternatives built on Kubernetes such as OpenShift?
Yes.
I'm not familiar with this one.
Yes, that's something that I'm very, very interested in. I'm actually currently using the Docker and Kubernetes and for building my simulator. All my simulator, they are based on this technology. So that's how I learned and this Docker. I mean, I was very impressed by this technology. I think it's very, very useful. I am developing the lab, but it's going to take a while. It's not going to be maybe in a few months. But I'm actually actively using that, and based on the experience, and every day I learn something more about that, I will develop that for that.
Yeah. Another question from Saud as well. Are you planning to support other languages such as Java?
I want to focus on the pick one language, as my official language of CITLab, because otherwise if I support a very different language, it's going to be too destructive. Yeah, maybe after I have the startup, when the startup take off, and now I may be able to have the actual resource to do that. Right now I don't, because just myself and with a limited fund from the government and maybe one student, and it's really limited what I can do. And there's some interesting idea. Expanding this to Java to other language, And also some people recommend to actually put the lab in the Raspberry Pi, which is a very interesting idea. Yeah, I want to do all of them. And so hopefully, and I will be able to get my resource so I can have a group of people and to work on that. Yeah, but at this point, I don't. I want to focus on Python. Python become the leading language now. And actually, it doesn't matter what language you're using. Once you understand the main idea behind that, and that should be, I mean, you can apply the same ideas to other language, to other platform.
Yeah, thank you. Now, also, I just like to point out that also you need experience on using Linux commands, because you are using Linux frequently in each class, so also you need basic knowledge at least in Linux. Now, Mr. Ibrahim, I'm not sure his full name, he's saying how we can contribute and help with the labs. Any ideas if others would like to help? And
I'd be great. Yeah, I'd be great. Yeah, as I said, I mean, there are several fields that I don't like digital forensics. So if any of you are interested in developing lab, and definitely we can work together and to work on that, and because the digital forensics is not my expertise. There are many other things that I'm not specialized in, like the digital forensics, binary analysis, and those kind of things. I'm very good at the fundamental part. That's where my strength is. But my research is on the mobile security. So I've been developing lab on the mobile security part, especially Android part. But other than that, I don't want to claim that I know everything. I definitely want to collaborate with people, with experts and like you guys.
Yeah, thank you. Another question, can we get a copy of these slides? Yes, definitely. And actually, we'll also post the recording for YouTube, so that also you can share the recording for this session. And also you can slides as well. Either contact Professor Du or contact myself. We'll be happy to provide you with the slides.
Yes, yeah, I will definitely provide the slides, yes.
Any further question, guys? I think the presentation was very informative. You covered everything from the history of seed labs and the 20 years journey, and we are sure that your efforts are amazing, and they are influential worldwide. We really appreciate your efforts, and this effort, I think, will help our students to improve their learning skills or in cybersecurity field.
Yeah.
Okay.
Thank you. I
One
see
further question.
Yeah,
are there different labs for beginners and advanced students? Yes, I think this one was answered by saying we have different difficulty levels.
Yes, yes. So some of the lab, and you can see, I marked them. Like for example, Buffalo Flow Lab is actually on the entry level, but Return to Libc, which is another way to attack the Buffalo Flow vulnerability, that is extremely difficult. So you can see I did mark them as a more difficult. And the VPN lab, and those are mostly for advanced students. I do teach computer security for both undergrad and the graduate level. And some of the lab I would never give to undergrads because of the level of difficulty is too overwhelming for undergrad students.
Yes, yes, that's true. Actually, yes. On behalf of all the attendees, I'd like to thank Professor Kevin for this wonderful opportunity, and thank you very much for preparing the slides and being with us and accepting our invitation, and wish you all the best in your future maneuvers. Thank you very much, Professor Kevin.
Oh, thank you so much. Thank you for the invitation. I'm glad to be able to talk. Yeah.
Thank you very much.
Okay, thank you, and talk to you later.
Thank you. Take care. Bye-bye.
Bye-bye.